Alright, thanks for all your thoughts so far. But, as I said at the outset, this is also going to focus on the next generation science standards. I wanted to get some background to see where's everyone coming from so we know what we're talking about. But let's take a minute to look at the different dimensions of the next generation science standards. I mentioned them briefly before. They're the disciplinary core ideas, what students know, the cross-cutting concepts, how students are thinking, and science and engineering practices. What are students doing? So cross-cutting concepts. Some important themes pervade science, mathematics, technology over and over again. So ideas that transcend the different disciplines. And understanding them in one area helps students understand them in all the others. This is from the framework, the document that underlies the next generation science standards. Let's glance at these very quickly. I know we don't have much time this hour. So we have patterns and cause and effect. These are the two fundamental concepts of science. That means we look at the natural world and we see things repeating over and over. And we think we can explain these through cause and effect. It's really positive anthropology of understanding if you want to get into the philosophy of it. But so these are what's there. It's two fundamental concepts of science and engineering. Also, things happen at different scales. It could be the size of quasars, it could be the size of neutrinos, it could be the size even smaller than that, and everything in between. The level that we're studying is hugely important to the question and how we approach it. Look at systems or ways of looking at the world, whether we're modeling it or explaining it. And systems can be described in their relation to energy and matter, things as they flow through, in, and out of a system. How structure and function relate, especially important in all areas. That's why it's a cross-cutting concept. But I think of human anatomy as one example of structure and function. Instability and change. Things can maintain the same patterns almost indefinitely until some other force interacts. Think of an orbit of a planet, although they slowly decay. But barring a meteor, they're not going to change dramatically. So stability and change. These three help explain systems. Science and engineering practices. I'm going to fly through these because there are 8 of them and they're all so much fun to do. But always a challenge how to get them in and do them well for the students to understand. Alright, it's a fantastic quote. You can read it. Asking and defining problems. Those are my students working really hard at understanding weather so they can explain to other people. Developing and using models. How do we develop and carry out a lab, a plan? How do we analyze and understand our data that we gather and explain what's going on based on our experiments and our numbers? Using mathematical and computational thinking, constructing and explanations and designing solutions. Engaging in argument from evidence. It's so important to be able to explain what you know and how you know it is the case. So again, communicating information. All of these, the science and engineering practices and the cross-cutting concepts, aren't typically what we've thought of in science education in the past. We've thought of the stuff, the discipline core ideas, which are essential. But combined with the other two, they can pop into 3 dimensions. They pop to life. And they become really interesting and really engaging.